And so once again, the following Zoom session is being recorded and it will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made known, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today, eventually, we're going to get to section 8.9, which is the last section we're going to cover. So tonight, you'll have 8.9 along with the chapter review as your homework. Tomorrow, we'll review and then the test will be on Thursday. I just want to remind you that the Math Center is available many hours of the day, and the ID number for that is 509-574-6827. So if you want to get instant help and I'm not available, you can always contact the Math Center. Okay, so I got a lot of emails from people wanting me to answer some questions from section 8.5. And so let's take a look at those. I think we've gone a little bit too far there. Okay, see if I can get that to come on. Somehow we'll figure this out. There we go. There we go. All right. So we have a number equal to an absolute value. It doesn't really matter which side of the equation the absolute value is on. I'm going to switch it around though, just because I just like to do it that way. So I'm going to deal with a problem like that. Okay. So then what's inside the absolute value? X over 5 minus 5x over 6 either equals what's outside or the opposite of what's outside. So we've got these 2 possible equations to solve. Any questions so far? All right. So the first equation, I'm going to clear the fractions. The least common denominator is 30. So I'm going to multiply both sides of the equation by 30. When I do that, distributing, I get 30 times x over 5 minus 30 times 5x over 6 equals 11/30 times 30. Going back and simplifying each product, 30 over 5 is 6 over 1, so I get 6x. 30 over 6 is 5 over 1, so minus 25x equals 11. 6x minus 25x would be what? Negative 19x. Is that right? Then divide both sides. What? It is? Yay. Okay, good. Divide both sides by negative 19. X equals negative 11/19. Okay. Now, let's go over to this other side and deal with this one. Here, once again, the LCD is 30. Can I save some time and say, can you see that all the steps are going to be the same all the way down to here, except instead of having 11, what am I going to have on the right side?
Would be negative 11.
Negative 11, okay. But can you see that everything else would be the same? We okay with that?
Yeah.
All right, good. So then negative 19x equals negative 11. Divide by negative 19, x equals 11/19. Okay. So we've got negative 11/19, 11/19. Do you want me to go through and check my work on this?
Sure.
Sure. Okay. I was afraid you'd say that. The only reason I was saying I'm afraid is because I've run out of room and I've got problems written there. But you know what? We'll fix this. We'll take care of it. Here's what we'll do. We will do this. So I will just create some room for myself here because I wrote out all the problems ahead of time and I thought about leaving extra room, but of course I didn't. Okay. So now let's take the negative 11/19. So negative 11/19 divided by 5 minus 5 times negative 11/19 all over 6. Absolute value equals 11/30. Oh, isn't this going to be fun? Ha ha! In fact, you know what I'm going to do? I'm going to take those answers. X equals negative 11/19. X equals 11/19. And I'm going to put them up there so that I can have lots of room to work with. Okay, so let's take a look at this little piece right there. That's negative 11/19 divided by 5, right? Which is negative 11/19 times 1/5, which is negative 11 over what, 95? Okay, and then let's take a look at this piece. Let's see, I've got negative 11/95 and then what, minus, let's see, 5 times negative 11/19 would be negative 55/19, but that's all divided by 6. So that's negative 55/19 divided by 6, which is negative 55/19 times 1 over 6. Wow. Which is negative 55 over what, 60 and 54? Is that right? 60 and 54? That would be what, 114? Oh, this is just awful, isn't it? So then this is going to be minus 55 over 114. Wow. Maybe it would be easier to clear the fractions again before we went through and did all of this. What do you think? Or get a common denominator? I don't know.
Oh.
It's just,
I don't know.
What's that?
This is a lot. I didn't say it.
This is a lot, isn't it? Yeah. Negative 30th. Let's see, what do we got there? So common denominator between 95 and 114, and I'm already suspicious. I'm going, did I make a mistake? Let's see. That's divided by 5, and that's divided by 6. 55/19, 6, 55 divided by 6, 55, 114, that's 60. 60 and 54. I guess not. Let's see, subtracting a negative would be like adding a positive. But now I need a common denominator for 95, 114, and for 30. And that just seems awful, doesn't it? Let's see. I'm gonna wish I'd had more room. 95. What's that? Oh, okay. 95 is, let's see, 19 times 2 times 3, and 114, let's see, 19 times 2 times 3, and 114 is what? Let's see. Hang on here. Hang on. That's not right. That's not right. 95 is what? How did we get 95? We took 5 times 19. So 19 times 5, and then 114, how did we get that? That was 19 times 6. So the LCD is going to be 19 times 5 times 2 times 3, which is, oh, let's see. That would be what, 114 times 5 is 570? Is that right? Boy, this is just awful, isn't it? So I think I think 570 is our least common denominator.
I'm sorry. I didn't know it was going to be this crazy.
That's okay. That's okay. Because, you know, it wouldn't be fair for me to ask you to do something and then me say, oh, I'm not going to do it. Let's see. I don't know that we're going to get through every problem, though. that I've got here, but that's okay. So if 570 is our LCD, 11, negative 11 over 95 plus 55 over 114. If we turn this into 570, we'd have to multiply that by 30. Is 30 times 95? No, that's not right. No, that would be 6 times 6, negative 66. And then this would be 5, which is, what's 55 times 5? Is that 275? And what's 275 minus 66? That's
209.
9 over 570. I'm very skeptical here. That's supposed to equal 11 over 30. Not so sure about this. I'm just, I can say, very skeptical of my work here. Let's see. Maybe all we're going to do is get this one problem done. All right, let's see. So I'm trying to decide if 209 over 570 equals 11 over 30. Well, if I take 5,
it reduces down.
Okay.
Yeah.
If I divide this by 30, I get 19. Let's see if we take 19 out of the top and 19 out of the bottom. 209 divided by 19. Yay! And 570 divided by 19. It does reduce. Thank you. Okay.
Good
That
job,
was the
Mr.
first one.
Mayo.
What's that?
You're done.
Good job. That was
Thank you.
extremely complicated.
Tell you, looking at that, I'm thinking, oh man, I'm just waiting for somebody to say, you know, Mr. Mayo, back there at the very first step, that was a 7 and you wrote a 6. No.
No,
Okay.
you nailed it.
When math 95 hurts the professors.
What's that?
It was like when math 93 even hurts the professors.
Yes, my head hurts. All right. I am going to go on. I'm not going to check the other answer. I know that's terrible of me, but because people asked a lot of questions and I want to kind of get through the process. But you know, and of course, I could have used my calculator, but oh, heaven forbid that. But anyway, all right, we're going on. Solve the equation. So when we've got an absolute value equal to an absolute value, we end up with what's inside equals of the first one equals what's inside of the second one, or what's inside of the first one equals the opposite of what's inside of the second one. Okay. So we end up with that situation. Any questions there? Solving the first equation, I'm going to subtract 3x from both sides. X minus 6 equals negative 29. Add 6 to both sides. X equals negative 23, which we'll come back and check here in a minute. Second equation, I'm going to distribute the negative sign, negative 3x plus 29. I'm going to add 3x to both sides. 7x minus 6 equals 29. Add 6 to both sides. 7x equals 35. Divide by 7, x equals 5. All right. And once again, we're going to check our work. And once again, I'm going to create some space for me to do that. So if you didn't get it all written down, you can check the video later to see what I did there. If x is negative 23, we get, oops, we get this. 4 times negative 23 minus 6 equals 3 times negative 23 minus 29, absolute value. Okay, here we go. 4 times negative 23 would be negative 92. Minus 6 would be negative 98. Absolute value would be 98. Okay, right side. 3 times negative 23, that's negative 69. Minus 29 is negative 98. Absolute value is 98. 98 equals 98. So this one checks. Okay. Any questions there? I like this one better than the last one. Okay, x is 5. Absolute value of 4 times 5 minus 6 equals absolute value of 3 times 5 minus 29. So this becomes 20 minus 6, which is 14, which is actually 14 outside. This is 15 minus 29, which is negative 14. Absolute value is 14. So that one checks as well. All righty. And let's take a look at another one. Basically the exact same idea, slightly different numbers, but we're going to take what's inside the first one equals what's inside the second one, or what's inside the first one equals the opposite of what's inside the second one. On the left side, we're going to add 2 to both sides, and we're going to get 6x plus 3 equals 9. Subtract 3, 6x equals 6, divide by 6x equals 1. On the right side, 4x plus 3 equals the opposite of 9 plus 2x. Subtract 2x from both sides. 2x plus 3 equals negative 9. Subtract 3. 2x equals negative 12. Divide by 2x equals negative 6. I know I'm going kind of quickly there. I have a feeling I'm going to end up bailing on some of the questions. And if I didn't get to yours, I'll check back later to see if you've still got questions. Or check back with me, because I think I deleted all the emails after I wrote the problems down here. But they're very similar. Okay, tell you what, let's just do this one in our heads. What's 4 times 1?
4.
Plus 3.
7.
What's the absolute value of 7?
7.
Okay, what's 2 times 1?
2.
What's 9 minus 2?
7.
What's the absolute value of 7?
Negative 7.
No, no,
Hmm.
absolute value is positive or 0.
Oh.
So it'd still be 7. Okay? You see it?
Yeah.
So like the absolute value of 7 is 7. The absolute value of negative 7 is also 7.
Okay.
That would check. Okay, let's do the negative 6. Of course, I totally obliterated the problem here, but 4x minus 3, what's 4 times negative 6?
Negative 24.
It's negative 24 plus 3.
Negative 21.
What's the absolute value of negative 21?
21.
Okay, what's 2 times negative 6?
Negative 12.
What's 9 minus negative 12? That would be 9 plus 12, which is 21. What's the absolute value of 21? 21, ka-ching, ka-ching, and it checks. Okay? We all right with that?
Yes.
Okay. This problem is just like the previous ones. You take what's inside equals what's inside, or what's inside equals the opposite of what's inside. The difference is here you would distribute the 3 or the negative 3 first, okay? This problem, same thing. This problem, that's another one like that nasty first one we looked at, okay? I'm not going to take the 3 hours it's going to take to do it and check our work with it. But again, you take what's inside equals that, what's inside equals the opposite of that, clear the fractions. Here, your LCD is going to just be 8. So that one's probably nicer than that other one. Same thing here. This is very similar to that one. Here's another one. 21 was a very unpopular one with you folks. So I'm not going to do like all those different ones. If you still got questions after seeing the examples I did, email me and I'll contact you personally and we'll go over it very slowly. Okay? All right. And everyone said, yes, of course, Mr. Mayo, sure, whatever. All right. Because I said there were about 9 or 10 questions people had, but they were very much like those. And again, if you still are struggling with it, contact me. Because I want to make sure we have time to get through the last section here. This is section 8.9, and the topic is variation. All right. There are three kinds of variation. The first one is called direct variation. It is in the general form of y equals k times x, where k has a bunch of different names, all meaning the same thing. It's called the constant of proportionality, the constant of variation, the variation constant. I tend to call it the variation constant because that's the shortest. So variation constant. What's going to happen is this. Ultimately, we're going to read a story. In that story, it's going to describe a kind of variation, in this case, direct variation. From that, we will establish a formula. They will then give us some information. We'll use that information to determine what k, or the variation constant, is for that problem. Then we'll use that information as a follow-up. Okay? Let me give you an example. So I've got a bunch of leaves in my yard, and would somebody be willing to come and work and rake those leaves? Any volunteers? We won't hold you to it, even though this is recorded. The whole world will know that. Anybody willing to come and work for me? Anybody? Anybody? Anthony?
I'll do it, Mr.
Okay,
Mayor.
thank you, Anthony. Good job. Okay, so
Anthony's a
here's
good student.
okay. So here's the scenario. If you will come and work for me for 5 hours, I will pay you $100. Okay?
Whoa.
Whoa, right. So we're going to say that X is the time and Y is the money. All right? So $100 equals K times 5 hours. Can you tell me what your hourly rate is, Anthony?
That would be $2 an hour.
Careful.
No?
I wouldn't be that cheap.
10. Why did I take out a zero?
I
Why
don't
did I
know.
take out a zero? I just neglected that.
Is that a little better? $20 an hour?
Yeah,
Okay.
that's a little better. There we
So,
go.
so my scenario is saying I will pay you $100 if you come and work for 5 hours. Okay. From that, we can establish that I'm going to pay you $20 an hour. That's the variation constant. So now, Roger, if you come and work for me for 3 hours, how much will I pay you? Well, let's see. That would be y equals 20 times 3 would be what?
60.
$60. Okay, so what did we do? Given this information, we were able to determine that the variation constant was 20, or in this case, the rate of pay, $20 per hour. Knowing that, then we could go to a new scenario and say, well, now if you work 3 hours, you'll make three times 20, $60. Okay, let's apply that to another problem, one in the textbook. And let me see if I can find this. Okay, so this says free fall. An object in free fall, in other words, an object's just falling through space, travels a distance s, okay, that varies directly to the square of the time t. All right, so I said varies directly. So the distance s varies directly to the square of the time t. Whoever's got the iPhone, can you mute your voice? We're hearing things going on. Thank you. Okay, so s equals kt squared. Now let's go back to this y equals kx. Okay, y equals kx. So why do I know it's that form? Because in the problem it said varies directly. Okay, it said the distance s varies directly as the square of the time. Now, notice k, the variation constant, is not mentioned. Quite often, it's not even mentioned in the problem, but you have to figure it out. All right, so I know from the reading, this is the formula that I'm going to use. Okay, now it says if an object falls 1,024 feet, so that's the distance, so that was S, 1,024 feet, in 8 seconds, so that's the time, how far will it fall in 10 seconds? All right, so this first bit of information is going to allow us to determine what K, or the variation constant, is for this problem. So 1,024 equals 8 times 8 is what? 64 times K. How would we go about determining what K is now?
Divide by 64.
Correct. Divide both sides by 64. All right, let's see. 1,024 divided by 64 is 16. So now that I know K is 16, okay, now my formula becomes this. So I took that and put it in the place of K, all right? Now I'm going to answer the follow-up question, and it says, how far will it fall in 10 seconds? So that would be 16 times 10 squared would be 100. So that would be 1,600 feet. So reading the problem, it said direct variation. So this was my model. It said that the distance varied directly with the square of the time. I went through taking the information they gave me, determined what K was, put that back into the formula, went to the new scenario to answer the new question. All right. Now, the biggest mistake that I see people make in this kind of a scenario is somewhere along the line, that squared gets lost. And at the end, they don't have 10 squared, they just have 10. So be really careful that as you move to each next step, you bring all the exponents along with you. Okay? Any questions about this problem? So this is direct variation. And now we're going to look at inverse. Let's see, variation. Okay. And its general form is y equals k over x. So who there, I know that, you know, maybe under a current situation, you don't go out and get coffee every day. I don't know. Do any of you still go out and get like a latte every morning? Anybody?
I don't do it
Not-
every.
but like often.
Sydney, is that you?
Not like all the time, but like pretty often. Yeah.
So how often? How often a week do you go and get a latte?
Justin, how often do we go get coffee?
What's that?
Like 2 to 4 times a week.
Okay, let's just go with the average and let's say 3. Okay. What do you pay for them?
It's like $5.
$5. Okay, so 3 at $5 a piece. Okay, just because you said 2 to 4. All right. What if the price went up to $8? Would you still buy 3 every week?
Probably.
Wow. Okay. So you'd buy $8. How about if they were 10?
No.
If they
I
were
would go
10,
to a coffee
they-
store.
what's that?
Go to a different coffee shop.
Well, this is the only coffee shop in the whole world. You have no choice.
Yeah.
So if it was $10, would you still buy 3?
Nah, man, I'd be making my own coffee.
What if it was $9? Would you buy 3 or would you maybe just buy 2?
2.
2, okay. So 2 at $9 a piece. And you said at $10 you wouldn't buy any?
No,
Not even 1?
probably not. It's just, it doesn't, I don't know.
How about $9.50?
I don't think so.
No, okay. Let's go the other way. What if they were, so you said that $5 a piece, you'd buy 3. At $9 a piece, you'd only buy 2. What if they were $4 a piece? Would you buy
Yeah,
more? Would you buy more than 3 a week?
Probably not. But
Okay. What if they were $3? Would you buy
sure.
it? How many would you buy then?
Probably just get one more.
So 4.
Yeah.
Okay. What if they were $2? Would you get 5?
Maybe.
Maybe. Okay. What if they were free? Would you get one of those hats, you know, that has like the spot for the cans, and you'd like have an intravenous needle and just coffee going into your body the entire time if they were free? Would that be you?
Yeah, if they were free.
Okay, okay. So let's kind of generalize what happened here. As the price went up, the amount you were willing to purchase went down. As the price went down, the amount you were willing to purchase went up. So this is inverse variation. As one goes up, the other goes down. As one goes down, the other goes up.
Okay.
And that's where you get this situation. Okay? Does that make sense?
Yeah.
All right. And we're not here to judge your coffee consumption, though you may get phone calls from all the coffee places in town later. All right. So inverse variation, we have this sort of a reciprocal situation. K is still there. It's on top. Now X is down below. All right. So let's look at an example of inverse variation. And here we go. Okay. So the frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. So we got this big pipe organ. You know, it's got these huge pipes, okay? And so when the air goes through it, it vibrates the pipe so many times. And it says, okay, the frequency of vibration, so how many times it vibrates per second, is it varies inversely to the length of the pipe. So we've got frequency of vibration, which I'm going to use a little f. So that's going to be, let's see, that's going to be frequency of vibration. And then we've got L is going to be the length of the pipe. Okay, so I'm identifying my variables. It says the frequency of vibration varies inversely to the length of the pipe. So F equals K over L. Remember, K is always there. It's always on top. The frequency of vibration varies inversely as the length of the pipe. So F equals K over L. Any question where I got this from? So now I'm going to use some additional information to determine K for this problem. It says, if a pipe 2 feet long vibrates 256 times per second, okay? So the length is 2, the frequency is 256. How many times per second will a 6-foot pipe vibrate? We're not ready for that yet. What we need to do now is solve for K. So if 256 equals K over 2, what would we do to solve for K?
Would you multiply
By?
256?
Okay. And which would give us what? 512 equals K?
Yep.
So now we know the variation constant. So now we're going to take that and put it back up here. So now we've got this formula, F equals 512 over L. Follow-up question. How many times per second will a 6-foot pipe vibrate? Okay, so L is the length in feet. So 512 divided by 6 is 85.3 repeating. So that's going to be 85 1/3 times. 0.3 repeating is 1/3. What's 0.6 repeating? Anybody remember? Two-thirds. 0.3 repeating is 1/3. 0.6 repeating is 2/3. Okay. You all right with this example?
Yeah.
We've got one more kind of variation. And let me find it here. This is called joint variation. Y equals K, and I think they use an X and a Z. Are any of you on a joint checking account? Do you even have a checking account? What is
Yeah.
it? Do you know what a joint checking account means?
No.
Are any of you married?
Me. We have a joint savings. but-
Okay, all right, joint savings account. So you and your spouse are both on that account, right? So a joint account means there's more than one person on it. Well, joint variation, notice that on the right side, there's more than one variable. K is still the variation constant, but now we've got Y equals K X Z. So we have direct variation, one goes up, the other goes up, one goes down, the other goes down. Inverse variation, one goes down, the other one goes up, etc. Joint variation, we've got more than one variable on the right side of the equation. Okay, so here we go. The number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. The constant of, or the variation constant is 23.5. Find the number of gallons that can be stored in the cylindrical tank shown. Okay, and I know I read all that through quickly. I'm going to come back and read it several other times, but I want to draw this lovely picture if I can. So we've got this oil storage tank, and we're told that it is 20 feet tall and 15 feet in diameter. Okay, I can't read that very well. This is 15 feet. So it's 20 feet tall, 15 feet in diameter. All right. So this is a storage tank for oil. All right. Now, the number of gallons varies jointly. So we've got to have, let's see, how about G equals number of gallons? That's a G, not a 6. Okay. H is the height of the tank. And R is the radius of its base. Okay, so G is the number of gallons that are in the tank. H is the height of the tank, and R is the radius of its base. Okay, so the number of gallons that can be stored in the tank varies jointly. So we're going to have K, even though it's not meant, well, it's mentioned later, jointly as the height of the tank and the square of the radius. So G equals KHR squared. The number of gallons varies jointly as the height and the square of the radius. Any questions so far? All right, now.
I had one question.
Yes.
I was just thinking how to ask it. So since you put H and R, are those just to replace X and Z for now?
Yes, yes.
Okay.
This is just sort of a general description, but each scenario is going to have a different set of variables that are given. But yes, that is correct. Yeah.
All right. Thank
This is just to show that in joint variation, you're going to have more than one variable on the right side of the equation. All right, now,
Okay.
Let's see here. They tell us that the constant of proportionality, or the variation constant, is 23.5. Okay. So there's K. Do we know H?
H is 20.
H is 20. Careful. Do we know R?
Wouldn't you have to do 15 squared to find R or no?
Okay, no, wait.
It'd be
R is-
half of 15, wouldn't it?
Yeah, okay.
7.5.
Oh,
This is the diameter. So R would be half of that, which would be 7.5. And then we're going to take that and square it. Okay? Do you
okay,
see where?
that makes sense.
Okay, good. All right. So calculator time, 23.5 times 20 times 7.5 squared. And I'm getting, let's see here, 26,437.5 gallons. So this tank right here holds 26,437.5 gallons of oil. I'd like to have that in your backyard. Well, okay. We all right with that?
Yeah.
So let's do a recap here. We've got direct variation, y equals kx. We've got, let's see, inverse variation, y equals k over x. And we've got joint variation, y equals kxz. So direct, they either go up together or they go down together. Inverse, one goes down when the other goes up, one goes up when the other goes down. Joint variation, you've got more than one variable on the right side. K is in each formula. K is always on top, and it's a constant, and they'll either give it to you like they did in this last example, or you'll use information given to figure it out. But the first thing you've got to do is read carefully to determine which kind of variation you're starting with. Okay. All right. I just want to say again, going back to, I had a whole bunch of problems here that people had asked about, and I didn't get through them. We've got time. I'm going to go ahead and do this one right here. Okay. If I didn't get through your problems and you still got questions, email me and I'll get in touch with you. But I just thought, after that first one, we could have spent from now till midnight just checking our work on these. Okay. So for this particular problem, you'd take what's inside equals what's outside. Excuse me, what's inside equals what's inside, or what's inside equals the opposite of what's inside. The biggest mistake that students make is they write it like this, whereas they should write it like that. You're taking the opposite of the whole thing, not just the opposite of the first term, or sometimes they'll change it to x plus 4. You're distributing, so it's subtracting, or the opposite of the entire insides, okay? So now going back and solving each one, here we're going to subtract x, 4x plus 13 equals -4, subtract 13, 4x equals -17, x equals -17/4. Here, let's see, 5x plus 13 equals -x plus 4, distributing like I talked about, add x, 6x plus 13 equals 4, subtract 13, 6x equals -9, x equals -3/2. So we've got -17/4, -3/2. Do you want me to check this one? No one has any comment. Do you want me to check it or not?
No.
No, you don't want to have to go through the torture even though I'm doing it. All right, then we're going to call it a day. So reminder, tonight you're going to do section 8.9 and the chapter review. Just a reminder about the Math Center. Let's see here. Phone number for the Math Center right there. And then on Thursday, we won't have any class meeting. You'll just take your Chapter 8 test. I will be back at 1:15. And like I say, if I didn't get your questions answered from yesterday and you can't make the afternoon meeting, email me, I'll contact you and we'll work on it together. All righty. Have a great rest of the day. And